the first thing is test for divergence. So let me just write this down here for you guys. So this is just like the preview of what we are going to cover, right? So test for divergence. This is the first one. And again, we are going to compare the difference between convergence. We are going to compare the difference between the convergence between a sequence and a series, right? So this right here, abbreviated as TFD, and it says the following, all right? This right here is really useful. It says, if today you take the limit as n goes to infinity of the sequence an, well, if this right here is not equal to 0, then you can be super happy because you get to conclude that the series as n goes from 1 to infinity, and in fact, the starting n value usually doesn't really matter, but as long as you go to infinity, and then right here, an, this series will diverge, right? So this right here is really useful and you should always check that. And you will also have to be good with taking the limits of any kind of expressions that you have done so far, right? So keep this in mind. Next, we will also need to know the geometric series. So let me just write this down here for you guys. Geometric series. And this right here has a special form. This is a series, and usually it's written when n is starting with 1, right? So it goes from 1 to infinity, and we have the first term, a1. And then we will have a common ratio, namely r, and then we are going to raise that to the n minus 1 power. Again, this is the usual form for it. And once you have this right here, let me tell you, you actually get to know if it converges or not. Well, better yet, if this right here converges, you will know that this right here will converge to a1 over 1 minus r, alright? However, though, this only works if the absolute value of r is less than 1. So keep this in mind as well. But this right here, it also has a special form. This is when n is equal to 1 to infinity. Keep this in mind. If you can somehow simplify the expression right here, and if you can make it into an minus an plus k. And what I mean by this is that, well, you have one term minus the other, and they are of the same kind. But they are just off by some terms. So usually you will see things like, for example, an is equal to 1 over n, and then an plus k. If k is equal to 3, then you are talking about 1 over n plus 3. And in the middle is subtract. So as you can see, they are the same kind, but they are just off by 3 terms. And sometimes the expression can be slightly crazier, but this is the idea. Now once you have this, you're just going to write down a few terms and then just cancel things out. So perhaps I'll just write it down right here for you guys. Write down a few terms, and so just write out a few terms and cancel it out. Write out, just say write out a few terms, then cancel. Yeah. Then just work it out. Alright. Because for this one right here, once you see it, you will know what to do. Alright. And then last one right here, this is everybody's favorite, namely the P series. Why? Because this right here is perhaps the easiest to see. Well, I will write this down here for you guys right here. This is the series when n goes from 1 to infinity, 1 over n to the p's power. This right here, you actually know if it converges or not right away, so I'll write this down. This right here converges if p is greater than 1, and that right there diverges if p is less than or equal to 1. Alright? And for this, this is almost everybody's favorite. And again, sometimes you may see, okay, the series goes from 1 to infinity, but maybe you will see n goes from like 3 to infinity, but the statement holds. And I want to just do some special mentions. Alright, honorable mention or special mentions, right? So just put down a note right here. If you have the series as n goes from 1 to infinity, 1 over n to the first power, this right here actually diverges, right? And it actually goes to infinity. And this right here is called the harmonic series. So it's just like a fancy name that you would like to use. Yeah, and you should actually, because the more you learn about this kind of things, you'll see more like names for this kind of things. Okay, so these are the things that you are going to keep in mind. And we are going to get started with the first question. We are going to do two parts. The first part is, does the sequence converge? Why or why not? And if it does, what does it converge to? The second part is, does a series, now once you add them up, does it converge or not? So that's a different question. And they are related, right? And this is perhaps the most important thing if you are starting to learn about series and sequence. All right, usually you try to figure out formula. So you are going to ask yourself, okay, how can we go from the first term to the next term, and then from the next term to the next term, so on, so on, so on. And it might not be too easy to see because the 5, but well, actually, I don't know. It's actually just multiplied by negative 1/3. Yes, it's divided by 3, but when you are doing geometry series, always look at this as multiplying by a fraction. So this is the same as multiplying by negative 1/3, right? So it should be pretty clear. Yeah. Right? So this right here is actually the geometry sequence. So let me just give you guys the first part. Again, the first part is to talk about if AN converges or not. First, notice that AN is just equal to, let's write down the first term, which is this, 3/5. And we multiply by the common ratio, which is negative 1/3. And then raise to the n minus 1 power, like that. And usually, you can just leave it like this. You don't really have to simplify, but that's just me. Depends on your teacher. Or maybe if you're taking a multiple choice question, maybe you have to simplify, do the algebra for that. But anyway, does AN converge or not? For this, we always have to check, right? We always have to check the limit as n goes to infinity of AN. And because we have the AN formula right here already, so we just do the limit as n goes to infinity. AN is that, which is 3/5 times negative 1/3 raised to the n minus 1 power. All right. And now it really depends on your teacher to see how much work that you have to show. But for my class, if you see, we have a limit as n goes to infinity, and this number, right, is negative 1/3 because the absolute, and you can see that the absolute value of negative 1/3 is less than 1. And then if you put this, right, infinity right here, then you can say that this right here is just equal to 0, right? So that's pretty clear. I think that will be the jet, I would say. Again, depends on how much of the work that your teacher wants you to show. All right, so this right here is 0. So therefore, the answer is that yes, AN converges, right? AN converges. And right here, we can actually say AN converges to 0. So this right here will be the answer for that. Part B. Part B says, does the series of AN converge or not? So we are going to check the series as n goes from 1 to infinity. N starts with 1, right, in this video. Of AN. Does this converge or not? This is very different than that. So right here, check this out. This right here means what? I will write it down for you guys. The series means we are going to look at all the terms right here, and then we are going to add them up. So it will look like we are going to add 3/5, and then plus the negative, so it's minus 1/5, and then plus 1/15, and minus, and so on, so on, so on. So that's what the question is asking, all right? But anyway, though, this right here is a special case because you know it's geometric, so we can just look at this and say this is the series as n goes from 1 to infinity. AN is that, which is 3/5, negative 1/3, minus 1 power. And again, because the absolute value of the common ratio, this right here is less than 1. This is 1/3, which is less than 1. So we know this right here converges by the geometry series. And better yet, we can actually compute the value of this. And to do that, we are just going to use the first term, which is 3/5, divided by 1 minus the common ratio, which is negative 1/3. So that's very nice. And again, this is legitimate because this is true. And now just work this out. This is 4/3 on the bottom, and then, yeah. And then let's multiply. So this is 3/5 times 3 over 4, so altogether 9 over 20. Right? So right here we'll just say this series as n goes from 1 to infinity of an, this right here converges by the geometric series, and it converges to 9 over 20, right? And maybe I should mention this right here as the geometric series somewhere, just to make it super clear, because the goal for this video is to help the calculus 2 students, right? First question, does an converge or not? So we're going to figure out a formula for an, and for this, I'm going to just write this down for you guys. Notice that the top is just always adding 1. So just kind of make a note for that. It's plus 1, plus 1, plus 1, plus 1, and so on. And on the bottom, it's always plus 4, isn't it? Let's see what an is. Notice, because we always add 1 on the top, so the top is actually what we call the arithmetic sequence. And this is how you can do it. The 1 is the common difference, that will be the coefficient of the n. And then, remember, n starts with 1. You put a 1 in here, 1 times 1 is 1. And you just ask yourself, 1 plus what will be 7? 1 plus 6 will be 7. So the top has the formula 1n plus 6. Well, don't worry, we'll do another practice down below, because the bottom is also a arithmetic sequence, because you always have 4. The 4, the common difference, is going to be the coefficient of n, so you put down 4n. And again, n starts with 1, put it here, 4 times 1 is 4. 4 plus what will be 15? 4 plus 11 will be 15. So congrats, that's our formula for that, right? And now, does an converge or not? Well, for this, we're just going to check the limit as n goes to, that looks like h, my bad. Does the limit as n goes to infinity of an, right? And then let's see, this is the limit as n goes to infinity of n plus 6 over 4n plus 11. Well, this is a rational expression, which is very nice. As n goes to infinity, this is like everybody's favorite limit question, because all we have to do is pay attention to the highest power of n on the top, and then the highest power of n on the bottom. N and n reduce out, but we actually get 1 over 4 for the final answer, like that. So, ladies and gentlemen, an does converge. I'll just write that down, and we'll say an converges to 1 over 4. So this is very nice. Now, for part 2, you know it, we are going to see if the series as n goes from 1 to infinity of an, does this converge or not? Again, what does this mean? It means that we are going to look at 7 over 15 plus 8 over 19 plus 9 over 23 and so on, so on, so on, right? This right here, right? Sometimes you'll see the question is just this, the series as n goes from 1 to infinity, and they will just have the an, which is n plus 6 over 4n plus 11. You're going to see how to deal with this question a lot, right, in calculus 2, especially the later section. You're not going to see other things. It's just like this right here, in front of you. You have to do it right away. If this happens, this is what you do. You always just look at this expression and do the limit on the side. If you do the limit, you will see that the limit is equal to 1 over 4. The limit of an is equal to 1 over 4. It's 1 over 4. This is so nice because 1 over 4 is not equal to 0. So you can say that this right here diverges. And this is how you can write down your work. Again, this right here, you can actually just say this right here diverges because if you take the limit as n goes to infinity of this part, which is the an portion, n plus 6 over 4n plus 1, this right here, again, as I told you, is 1 over 4. But just, don't write down 1 over 4. Don't just write down 1 over 4. The most important thing is that you are going to write down this is not equal to 0. This right here diverges because of this right here is not equal to 0. So right here, I'll just say the series n goes from 1 to infinity. This guy, let me just write it down, right? This right here diverges, and we can just say by test for divergence. So this right here is how you can write down your reasoning for that. And again, this is the little word I got to show. And again, yes, we know we did this already, but I'm just saying that if you have to do this question on your exam, which you will have to, most likely the question is just this, right? They wouldn't tell you to do the first part. Then in that case, always do the limit on your own. If it's not equal to 0, congratulations, we can go from here to here and say this right here diverges by test for divergence. Well, why is that? When the limit is not equal to 0, this right here diverges right away. Here's the idea. Remember, this right here means that we are looking at all these numbers, and then we are going to add them up, and we have infinitely many terms. Well, the limit is being 1 over 4 right here is telling you that eventually we are going to add 1 over 4, 1 over 4, and so on, so on, so on. Infinitely many of them. And now imagine, if you have to add up 1 over 4, right? Approximately speaking, like this is about 1 over 4. If you're adding up all this right here infinitely many times, what will happen? Well, it will get bigger and bigger, isn't it? Yes. So this right here will actually go to infinity. That's it, right? So when you don't see this being equal to 0, you can be really happy for that. So here's the deal. This right here is actually the same as 2 over 4. Right, so, no, sorry, this right here is the same as 2 over 2. And this right here is the same as 2 over 4. And remember, n starts with 1. So this is the same as 1 times sine of 2 over 1. And then 2 times sine of 2 over 2. And then 3 times sine of 2 over 3, the 3 match, and the 4 match, like that. And last one, same thing. So anyway, same thing. Part A, first we know an. The formula is just n times sine of 2 over n. Does this converge? Well, let's have a look. We are going to check the limit as n goes to infinity of an. Right? This is how you check if an converges or not. So, check the limit as n goes to infinity. An is that, which is n times sine of 2 over n. Now we have a small trouble, because if you put infinity to here, we get infinity. And if you put infinity to here, 2 over infinity is 0. Sine of infinity is, so sine of 0 is 0. So this is actually a infinity times 0 situation. I'm going to remind you guys what the secret weapon is. Perhaps I will do it right here. Recall. Yeah, recall. This is one of the secret weapons. The limit as theta goes to 0 of sine theta over theta, this right here is equal to 1. Alright, and please do not do L'Hopital's rule for this. Just use this and then we'll notch up here and then yeah. So for this right here, we can actually do some substitution and we can put this into this form and that will be it. And the way to do it is we can let theta, so I'll just put this down, let theta equal to 2 over n. And of course, we can just multiply n on both sides and divide theta on both sides. Then you will see that n is equal to 2 over theta. And because n goes to infinity, you can see that if you put that right here, 2 over infinity is 0. So you can see that theta will go to 0. So we can take this limit into the theta world. Limit as theta goes to 0 now. And you see n is equal to that, namely 2 over theta. And then here we have sine of 2 over n, which is theta. Right? And cleaning things up a little bit, this is the constant multiple we can put in the front. So here we have 2 times the limit as theta goes to 0. And then put this over that, so we have sine theta over theta. Well, this right here is precisely the limit, and that will give you 1. 1 times 2, we get 2. So that's it. So finally, we can say that an does converge, and it converges it converges very nicely to the number 2. So this is it. For part B, again, does the series as n goes from 1 to infinity of an converge or not? Well, I'm just going to write this down. Most likely, later on you will see the question being asked like this, right? The series, and then they will just put down the formula n times sine of 2 over n. If this is what you are dealing with, again, go ahead and take the limit on your own, but because you can do the test for divergence. And you'll see that, hey, this right here, the limit is equal to 2, which is not equal to 0. So does this converge or diverge? Yeah, diverges. Nice, TFD, right? We did that earlier. And again, this is just how you can write down the answer. So you can say this right here, diverges because, again, I'm just putting this down right here under the assumption that we are doing this on its own. So that's why you will just say the limit as n goes to infinity of that, right? You do a limit of this part, right? You put this down and you show that this right here is equal to 2. And again, 2 is not equal to 0. Therefore, you can draw the conclusion. And the conclusion is that the series as n goes from 1 to infinity of an, right? In this case, this right here, diverges. And give a reason by test for divergence. Right? So that's how you can present your answer. Okay, an, right? First one, figure out formula. An, everything on the top is just 1, so it's 1 over this 2. It's the same as square root of 4. So all in all, in fact, this is just 1 over square root of n, right? So that's pretty clear. And again, does an converge or not? Well, let's go ahead and just do the usual thing. I want to be consistent throughout this video, so that's why I keep putting down the check, and we'll check the limit as n goes to infinity of an. And this right here means we will just check the limit as n goes to infinity of that, right? Put infinity to here, you can work this on your head. Square root of infinity is infinity. 1 over infinity is 0. So all in all, this right here gives you 0. All right? Good. So this means an converges to the number 0. So this is very nice. Right? Now, for the second part, we are going to see if the series as n goes from 1 to infinity, 1 over square root of n, converge or not. I showed you guys 2 questions previously, right? Number 2 and number 3. Now we can just use the test for divergence. Well, this time though, if you look at this, if you want to take the limit of 1 over square root of n, which we did, we will end up with 0. But it does not mean this series will converge right away. It does not mean anything. If you see the limit of an being equal to 0, we cannot draw any conclusion. The only place that we can draw conclusion is that if the limit of an is not equal to 0, then that's the test for divergence. Well, too bad in this case, but this is not so bad either, because the deal is this right here is the same as saying the series as n goes from 1 to infinity of 1 over n. Square root is the same as 1/2 power. So in fact, this right here is actually just the p series. And this is how I usually show work to my students. I tell them to circle the power right here and just put down, okay, p is equal to 1/2. And when you put this down, I know that you are using the p series, but do not just put down p is equal to 1/2. You will have to tell me that 1/2 is less than or equal to 1. Because you are telling me that p is less than or equal to 1, therefore, this right here diverges. So right here we can just say the series n goes from 1 to infinity of an. Right, so this right here actually diverges. So I'll just write down this right here. Diverges. And we can just say by p series. All right? So this is everybody's favorite, I will say. First part, does an converge or not? Well, we will just check the limit, I'll just put this down right here, as n goes to infinity of an, right? So this right here means we are going to check the limit as n goes to infinity. An is that, so just write that down. All right. The fact is, if you have the limit as n or x, whatever letter that you're using, doesn't matter, goes to infinity, and if you have 1 plus a over n raised to the bn power, this right here, it's equal to e to the ab power. It's very nice. And for my class, I tell my students this so you can use it without showing any other things because it's convenient. And I also make them do the proof of this so they know how this is true. And then after that, we'll just use this as a formula, right? So in this case, this is how you can show work, especially if you're in my class. Notice this right here fits into this form, and pay attention to the a value is actually -1. So you'll just write down a is equal to -1, right? A is equal to -1, and then the b value is just 1. So you just write down b is equal to 1. So all in all, you can just write down this is equal to e to the -1 times 1 power. Of course, this is just equal to e to the -1, and that's 1 over e, right? Therefore, we know that an does converge, so let's put that down. An does converge, and an converges to 1 over e. All right? And this, I think some of you guys are very happy about this already, right? Anyway, this is the fact. Earlier, I called that limit the limit. If you guys have seen this before in my old videos, thank you. And if you are taking Cal 2 for the first time and you're watching this for the first time, then you know that's one of the things that you'll see. Okay, that's an converges. Now, part B, does the series of an converge or not, right? So again, this notation, does this converge or not? This is asking us to do the series as n goes from 1 to infinity of 1 minus 1 over n raised to the nth power. One more time, you're going to see just this for the question. And when you see that, what you do is do the limit on your own, on the side, and then you see that the limit is equal to 1 over e, which is so nice, isn't it? Because you know this right here, diverge, because, again, supply that if you are doing this on its own, because the limit as n goes to infinity of 1 minus 1 over n raised to the nth power, this right here is equal to 1 over e, which is not equal to 0. Therefore, we can just say the series n goes from 1 to infinity of an. This right here diverges by test for divergence. So hopefully, by doing these 5 questions already, you notice the difference between an converges versus the series of an converges. So this is the formula that we have. Again, first part, does an converge or not? So let's go ahead and just do the check. So we're going to check the limit as n goes to infinity, and then just this right here, right? So an. And notice that I always write this down in this video because I just want to show you if you need to check if an converges or not, you have to do this. And then the next step is this, which is that. So you can skip this part if you would like, but anyway. All right, plus 2. Now, check this out. If you put infinity to here, you get, let me just put this down so we can follow along. We get e to the 1 over infinity, and then minus e to the 1 over infinity plus 2, right? So that's pretty much the idea. But this right here is just 0. So e to the 0 is just 1. And then minus, again, this is also e to the 0, which is just 1. Perhaps I'll put this down in red. Sorry about that. This right here, 1. This right here is 1. So finally, you can conclude that this right here goes to 0. Right? So if you want to show some kind of work, that might be okay. But anyway, though, this right here is also pretty clear that it's just equal to 0. So Does AN converge? Yes, AN converges. And we know that it converges to the number 0. Perfect. Well, this right here is the series as n goes from 1 to infinity. And again, I'm just going to write down the AN formula. For the first time of the day, this is a telescoping series. Why? First, the subtraction might give you a big hint, right? So pay attention to that. But more importantly, notice that this and that, they are of the same kind, but they're just off by 2. So that's why this is a telescoping series, right? So that's the idea for that. Now, check this out. This is how we can do it. I'll show you guys a fast way to get the answer, and then I will show you guys why this is true. So I'm going to leave a space right here, right? So this right here, the fast way to do it is pay attention to the starting n value, which is 1 in this case. You are going to put the 1 into the first term right here. So I'm going to write it down like this, e to the 1 over 1, right? And then we are going to add, and the reason that we have to add is because they are off by 2 terms. So we have to do this twice. The first thing is n is 1. You put a 1 in here, which we did. Then the second thing is that when n is 2, you put that right here and then you add them up. So we have e to the 1 over 2, right? And again, because they are off by 2, that's why you do this twice. N is 1, put it here, n is 2, put it here. You can imagine if this is n plus 4, then you do it 4 times. Then you end up with e to the 1 over 1 plus e to the 1 over 2 plus e to the 1 over 3 plus e to the 1 over 4. Right? That's the idea. Okay, but this is not it yet. What you want to do next is write down the last term right here, and that's minus. So you're just going to write down, we are going to minus, so put this down in blue, minus, minus this term, which is e to the 1 over n plus 2, right? You put down the last term right here. But again, because they're off by 2, so this is the last term. You also have to write down the previous to the last term, which is just 1 less than this, which is e to the 1 over n plus 1. You just decrease this by 1. So 2 terms in the front and 2 terms at the end, like that. And I'll show you guys why this is true, right, in a sec. So this is how you can write it down, and in fact, this is what we call the nth partial sum formula, especially when you have a telescoping series, right? But this is not it yet. What we want to do is, after this, we are going to take the limit as n goes to infinity. Because remember, this right here means that we are going to add infinitely many terms right here, right? All right, now check this out. This right here is just a number, this right here is just a number, but this right here, when n is infinity, you put it here, you get e to the 1 over infinity plus 1, which is e to the 0th power. So in fact, this guy will approach 1. Likewise, this guy, when n approaches infinity, this is e to the 0, and we will get this being approaching 1. So all in all, this right here is actually e to the 1st plus e to the 1 over 2. If you would like, you can write it as square root. Right? A little bit fancy, I will say. Minus 1, minus 1. Do not put that down as minus 1, minus 1. Please. Write it down as minus 2. Yeah? Anyway, though, this right here, we know that the series as n goes from 1 to infinity of our an, which is that. This right here converges. And in fact, we know what it converges to. It converges to this. E plus square root of e minus 2 by telescoping. Right. It's not really like telescoping test, but it's just a telescoping method to end up with that answer. So let me just write that down for that. Remember earlier I told you guys write down some terms and then we're just going to cancel things out, right? So the first deal is that we're going to put down 1 into the n's. That's the first term. So for the first parentheses, we'll get e to the 1st minus e to the, put a 1 in here, we get 1 over 3. So we have 1 over 3. And keep in mind, this right here is the first term.
Next, when n is 2, you put it here, so you have e to the 1/2, and then minus, put the 2 here, so you have e to the 1/4. Yep. So that's the second term, and then just write down a few more, which is e to the 3, right? 3 in here, which is 1/3, and then minus e to the 1/5, and then plus, let's put down one more. When n is equal to 4, put it here, so we have e to the 1/4, and then minus e to the 1/6, and so on, so on, so on, right? Well, we are going to write down the nth term as well. So the nth term is going to be just this, namely e to the 1/n minus e to the 1/n plus 2. And after that, keep in mind there's a plus dot dot dot. Right? This is just you stop at n. Well, because they are off by 2 terms, you should also write down the term beforehand, which is going to be you substitute n minus 1 here and here. So we get e to the 1/n minus 1 plus, sorry, let me just write it down better because it's not clear at all. E to the 1/n minus 1, and then minus e to the 1/n plus 1. All right, we good so far? This is the write out, and then I'm fitting everything right here. I'm pretty happy about it. Now, you see that when we write down everything, it's like this long, right? But the truth is, hey, we have negative e to the 1/3, but here we have positive e to the 1/3. So we can cancel this out and that. So it starts to clap, right? This stays, and you see this right here, e to the 1/2 also stays because you don't see another e to the 1/2. But if you look at negative e to the 1/4, guess what? We have this e to the 1/4. So this and that get cancelled. And now you see, in this parentheses, this guy get cancelled first, right? Keep that in mind. Anyway though, here you can see that negative e to the 1/5, this right here will cancel out with this term. I just didn't write it down. And then so on, so on, so on. This guy is going to cancel with some guy right here. So, in fact, these guys, they are going to get cancelled out. Now, notice that we have this and that survive. That's what we did. But don't forget that you also have to pay attention to the nth term right here. And as I said earlier, in the parentheses right here, this guy get cancelled out first. So if you look at this, well, here we have e to the 1/n. This is going to get cancelled out with some guy in the front right here, isn't it? Yes. And if you go to the previous term, this guy is going to get cancelled out with some guy beforehand, isn't it? Yes. That's why when they are off by 2, just write down the first 2 terms right here by doing what I told you. And then also write down the last 2 terms like that. Just put this down right here and then go to its previous term. That's it. You can go from here to here in my class, but I'm not sure about your teacher. Maybe your teacher wants to see the cancellations. Then in that case, do that. But you can also remember the shortcut is this. All right? So hopefully this is okay. One thing though, you will have to check the limit right here. A lot of students, they tend to forget about the limits for this. Yeah, because they think it's always equal to 0, but that's not true. Sometimes if this right here doesn't exist, then you don't have a limit for the series, so that's bad. This right here, it's not so bad. You'll see. First, check if an converges or not. So by that, we will check the limit as n goes to infinity, and an, which is just the limit as n goes to infinity of that, which is 1 over square root of n plus square root of n plus 1. Well, here we can actually just put infinity to here. You get square root of infinity plus the square root of infinity plus 1. On the bottom, it's just going to be infinity. 1 over infinity, you get 0. So all this is just equal to 0. Therefore, we can say an converges, and we know that it converges to the number 0. Done. This does not do us any good in terms of finding the convergence of the series as n goes from 1 to infinity of an. We have to do more work. Yeah. Anyway though, to check this, we are just checking the series as n goes from 1 to infinity of 1 over square root of n plus square root of n plus 1. Right? Now, imagine you see this later on. Yes, you can use what we call the comparison test to finish this. Right? That's totally okay. But again, this is the introduction video, so we're not there yet. That gives us 0, so we have to do more work for this. This is what we can do. We can do the conjugate. Have a look. Right here, I'm going to multiply the top and bottom by the conjugate of this, and the reason for that is because we see we have the square root in the rational expression. That's usually a good idea to go. Therefore, let me multiply the top and bottom by square root of n minus square root of n plus 1, and then let's do the same thing on the top as well. Now, check this out. When we multiply out the bottom, this right here becomes what? This is just going to be this thing squared, which is n, and then minus this thing squared, which is n plus 1. Right? And n minus n is just equal to 0, and then minus 1. So technically, we have a minus 1 right here. All right, so here we have negative 1. Let me put the negative 1 in the front of the summation. So I just want to make it slightly more clear for you guys. Right? Negative 1 in the front already. And then we have the series as n goes from 1 to infinity. And we have just this, namely n in the square root minus square root of n plus 1. Alright? This is the reason why I did it this way, because you can see that, yes, this right here is a telescoping series. But check this out though. This right here, we still have the negative all the way in the front. And let's do what we did earlier, right? This time, this and that, they are just off by one term. So I'm just going to put the 1 in here one time, so we have square root of 1, and we are done. And then we're going to look at this and then put that down, which is negative square root of n plus 1. Yep. So that's what we did earlier, and don't forget that we will have to take the limit, as n goes to infinity. So again, we change this to limit because we are doing the telescoping thing, right? So that's why this becomes a limit, because this right here is technically the nth partial sum for this guy already. Well, in this case, you'll see as n goes to infinity, this guy goes to where? Infinity. So have a look. Technically, if you would like to just do some computation, this is going to be negative, and then we have 1 minus infinity. So all in all, this right here is actually just going to be infinity. Right? This right here is actually going to be infinity. So therefore, we know that this series, as n goes from 1 to infinity of an, this right here diverges. And the reason is because we have shown that this right here is going to give you positive infinity. So it diverges to infinity. But you can also quote the reason. You can just say by the telescoping thing. There we go. Nice. Part A. Does an converge? Again, that means we are just going to check the limit as n goes to infinity of an. So this means the limit as n goes to infinity. An is that, so let's write that down, 2 to the negative 2n, and then 7n. Notice that both of them have n, so we can put the nth power on the very outside. So if you would like, you can look at this side, the limit as n goes to infinity. Again, this n and that n, we can just put that on the outside. So here we are looking at 2 to the negative 2 times 7, and then raised to the nth power. 2 to the negative 2 is equal to 1 over 4, so you can just write this down as 7 over 4. So this right here is really just the limit as n goes to infinity, and then we will have 7 over 4 raised to the nth power. This right here is infinity, right? Because this number is bigger than 1 raised to the nth power, so this right here gives you infinity. And do not say an converges to infinity. No, you just say an diverges. You can say an diverges to infinity. That's fine, but just leave it like this. Maybe even better. An diverges. That's all. Okay, so for part B, check the series as n goes from 1 to infinity of an. Does this converge, right? So an is that, so let's write that down. We are checking the series as n goes from 1 to infinity, and let me just write it down as how it has over there. And you can write this down like that, which is the series as n goes from 1 to infinity, and then we have 7 over 4 raised to the nth power. And by this, you can say it diverges. Why? Because you notice that this right here is a geometric series. And to do so, you can just say r is equal to 7 over 4. If you look at the absolute value of r, this is the absolute value of 7 over 4, but don't just tell me that. You have to tell me that this is greater than 1. And I insist you guys to write this down, because later on we'll be using different numbers in different tests to tell us if the series converges or not. So get used to this kind of things. So because this right here is greater than 1, therefore the series diverges, you can write it down like this, no problem at all. Or you could also have said, let me put down 2 of them. You can say this right here diverges by geometric series test, because the absolute value of r, right, is bigger than 1. So you can put it down like this. So no problem at all. Or you can also say this right here diverges because the limit of that, so I'll just say the limit as n goes to infinity of the 7 over 4 to the n, this right here is equal to infinity, which is not equal to 0. If you put this down right here though, then you will just say the series as n goes from 1 to infinity of an diverges. If you use this, you will have to grow by test for divergence, right? So it depends on which route that you want to take. Yeah, so both are okay. Perhaps this one is better because we are talking about the geometry series already on the 6. All right, so this right here, right, we have covered 8 questions comparing the convergence between a sequence and its corresponding series. Hopefully, all this right here will be helpful. And don't forget, we do have 8 more questions on the file, so try them on your own.